Hi, welcome back. This is Joe with routerfreak.com, and today we're going to be discussing the physical part of our network, and more specifically we're going to be reviewing physical connections and how this relates to what we're doing here in networking. A lot of people who get into networking or become network engineers, they come from an area or career field that is very familiar with the physical connections. I know me myself, when I first started, I was pulling cable. And a lot of people start this way. You don't have much experience, say maybe coming out of high school or coming out of college, and so you take a job that where you're pulling cable, and you learn a lot about pulling cable. And I think really it's a great foundation for understanding what's going on in the network world when you truly understand what's going on with the physical layer of the OSI model. So what we're doing today is we're going to talk about network cards and Ethernet cables and some of the common Ethernet cables that you'll see in use today, the different types and the specifications that are related to those Ethernet cables. And then we'll get into Cisco devices and how they connect to the Ethernet LAN. So let me get my little pointer out here, and let's get on the move. So here we go. Here's some network connections. This should look very familiar to you guys, right? We have a NIC card, a network card that goes in a PC. Looks like a PCI card. Over here on the left, we have, it looks like a 3550 maybe switch, or some sort of Cisco Catalyst switch. But this would be the switch side that you would see. Here we have an Ethernet cable plugged in to our switch. And then down here, this big picture, this is what you want to see in your data center or in your telco closet. You want to see a nicely bundled or nicely arranged switch, so where it's not quite a spaghetti mess like they tend to be. Now, of course, this really could be a lot better. See here, we have some notice here. Nice piece of Velcro that bundles up our group of Cat5 cable. Technically, you'd want to see this bundled up. You want to see this Velcro around all the bundles. That way we keep them nice and neat. This closet here is definitely a well-used closet, because you can tell these cables have been pulled. They're not in a nice tight bundle. They've been pulled. They've been probably moved around a lot. And that happens. I mean, that's part of operations. That's part of what happens day to day. Notice down here too, look at this gray cable here. This is your console cable going in to this. This is a 6500 series switch with redundant supervisor cards. Each one of these cards right here, this is a supervisor card. This is another supervisor card. And then we have some fiber, 1 gig fiber, most likely 1 gig fiber uplinks to, say, either our core or our distribution, depending on the scenario. But this switch here, this is nicely neat. I've seen some better ones, but I've also seen a whole lot worse cabling jobs, that's for sure. But you want to make sure that your cabling is nice and neat. You want to make sure that the bends here, when the cable gets bent, it's not bent too sharply, especially your fiber. Fiber needs to have nice slow bends, because this is glass inside of here. And so if this fiber were to bend, if this fiber cable gets bent a little too sharply, it'll break inside. And we'll go over the differences in fiber optic cable and some of the things to look out for, and I'll show you some pictures of what some of that looks like. But this is just a real high-level overview of our network connections and what they should look like. So network cards and Ethernet cable. So we have two different types. From a twisted pair standpoint, you can have shielded and unshielded cable. Now this is traditionally, this right here, this is your copper. This is your copper cabling. This is not your fiber. We're talking just copper cabling. And copper cable comes in two different models, so to speak. You can have it shielded twisted pair and unshielded twisted pair. The shielded basically, and just as the term implies, there's some metal. There's a metal sleeve that's inside the plastic insulator that's on the outside that you typically see. The metal shielding is there to help cut down on noise. You might use shielded cable if you're running a lot of data cable, this data copper cable around a lot of power. Or traditionally, really, you have a lot of your power sometimes will be shielded also, because power uses copper too, just like your data. That's the difference. You also hear data referred to as low voltage cabling. Well, with data cable, there is a voltage. There's a very, very slight amount of voltage, and especially if you start getting into power over Ethernet, where you can power wireless access points or voice over IP telephones. A lot of those can receive their power from the cable, and you can send that power down the copper cable. The most common you'll see, however, is this unshielded twisted pair. And really, the difference here and why we don't have any shielding is when you're twisting, when they make the cable, they'll twist the wires themselves around each other, and it's this twisting that helps alleviate some of the noise, that cuts down on some of the noise, and we'll talk about that here a little bit later. So with the different types of unshielded twisted pair cable that you can have, here's probably the most common that you've probably heard of, and that's your Cat5 cable. And Cat5 cable is your standard 100 megabits Ethernet cable. Goes about, your distance that you can run is about 100 meters or 328 feet. Lately, you may have been seeing a lot of Cat5e cable, and the Cat5e is your gigabit cable. And and a lot of times, if you're replacing your cable, you're probably replacing your Cat5 with Cat5 or Cat6, because more and more desktops and laptops are coming out with gigabit network cards. So if you're going to have a gigabit network card, then you need to make sure you have the physical infrastructure that will support that gigabit traffic. The cool thing about what's happening as these new standards are coming out is that the Cat6, Cat5e, they're all backward compatible to Cat5. And what that means when I say backward compatible, it means I can pull Cat6 throughout my office building or throughout my warehouse or wherever it may be, and know that my older devices, my older PCs and laptops that may only have 100 megabits will still be able to use the same physical cabling. And remember back in the earlier modules when I was talking about standards and why we have the OSI model. This is a great example of why you want to have standards that when manufacturers create the cable, they create the cable to a physical standard. There's a physical standard as defined by the OSI model that says that this physical cable will allow certain data characteristics to be certain data types to be able to be used for, the cable can be used for certain data types. And Cat6 is backward compatible to Cat5. And now this Cat6 is will handle data rates above 1 gig. If you notice over here, excuse me, if you notice over here, I have 3 gigabit, 3,000 megabits, and I haven't seen any NIC cards out there that are 3 gig NIC cards. That's kind of silly. But what we are seeing lately we're seeing a lot of 10 gig. So we've made a leap, haven't we? We've leapt from 1 gig and we're leaping over to 10 gig. And so Cat6A is backward compatible all the way back to Cat5. Now it supports 10 gig at 100 meters. But the reason we have this Cat6 is that what's different, I guess, that I should say about Cat6A versus, say, Cat5e or Cat5 is the quality of copper, and the number of twists that occur down the cable. So Cat 5 and Cat 5e, the copper will be twisted around each other, say, and I'm making this up. I really don't know the exact amount, but it'll be twisted, say, 5 times every foot. Whereas Cat 6 will be twisted every 15 times a foot or something like that. So there's more twists, and these twists help cut down on the interference between each of the fiber cables, and will cut down on the, and that's where that noise comes in, that interference that you see, because it's that low voltage, like I was talking about. There's minute amounts of voltage, and that voltage does bleed over into the other cables. If I were to draw it out here, like here down at the bottom, say I had a piece of wire, and then I had another piece of wire, and as these two pieces of wire run side by side, say I have some data running down this cable, and I have some data running down this cable. Well, the minute amount of voltages that occur in this cable will actually, it's called, the principle is inductance. It's an inductance principle. It's an inductive reactance. It's what it's called in electronics. You'll see an inductive force, or an inductive magnetic force. You'll have magnetic fluctuations that will affect the cable right next door to it, and vice versa. This cable, the voltage in this will generate a magnetic field that will affect the characteristics of the wire next door to it. So what they do is they then take this cable and they twist it around each other. They have the cable twist around each other, and what this twisting does is it's twisted at a certain rate that will alleviate that, it'll cancel out that magnetic inductive interference that occurs between the two wires. So if that makes sense to you. And then, okay, one other thing I wanted to touch on here. So we have Cat 6A, and notice we have this Cat 5E. If you look at the standard, if you look at the way the IEEE has defined the standard for Category 5, Category 6, Category 7 physical cable, the 5E, the E, you can think of the E as extended. I think it's extended is what the E stands for, or enhanced. And then the Cat 6A is... oh, geez, I've lost it. The A stands for, oh, damn, I can't remember what it is. It's essentially extended or advanced. Oh, I had it for a second. Okay, well, anyway. Essentially, it's just the Cat 6A is enhanced or advanced. I'm missing the word. But it takes it can do just a bit more than the Cat 6. Again, it's 10 gig. And then if you start getting into the Cat 7, which the standards, I don't know if these standards have been ratified, meaning I don't know if these are agreed upon by all the standards organizations. But we start getting up into Cat 7, we'll do 40 gig, and Cat 7A will do 100 gigabits. Now that is some smoking stuff, but if you think about the future and the way communications is going to go, we'll be seeing this. Give us 10 years, we'll be seeing this Cat 7A stuff here in a little while. So here we go. Here's some of our the naked truth, so to speak. We've pulled the shielding back off of these cables. So here's a Cat 5 twisted pair, unshielded twisted pair. And you see how we have our different twists in the wires. Notice how they each twist at a certain rate. Now, if you look at our Cat 6, see how the twists are much more tight. They're much more tightly wound with each other. We have a color code. It's the same. It's a very standard color code. We have the blue, white, white, blue, orange, white, white, orange, green, white, white, green, and brown, white, white, brown. And it's consistent across all our different types of cable. The big difference is the amount of shielding, the quality of copper, and the number of twists that we see in the in the data lines, or in the copper line, sorry. And that's what allows us to, the data to travel at higher speeds for the same amount of distance. Fiber. So now when we get into fiber optic cables we're starting to get into a completely different technology where we're talking about light. And we're talking about characteristics of light. I guess you can think of it as with copper, we were dealing with electrons, electron flowing down a conductive piece of metal, which is the copper, versus now we have photons that are bouncing around down a piece of glass, that are reflected down the piece of glass. So there's two different types of fiber optic cable that you'll find. There's single mode fiber and multi-mode fiber. And an easy way to think of the differences between single mode and multi-mode. Multi-mode is, and you know, if you look at the terms, you may think, okay, multi-mode, multi-purpose. Hey, this is better than single mode, single purpose. But don't get them confused. Multi-mode you'll see multi-mode is shorter distances, typically shorter distances. It's cheaper. It's cheaper to manufacture multi-mode cable. It's much more flexible. It's thinner. This down here, if you see this orange cable here, this is multi-mode. Right here, this is our multi-mode cable. It's typically orange. It's colored orange, and it's a thinner cable. Single mode down here, if you see this yellow cable down here, if you look at it, it's a little bit thicker, a little bit hardier piece of glass. This is our single mode cable down here at the bottom. This would be our single mode, and this is typically colored in yellow. Now these can be any colors. You can order your fiber optic cable in any color you like, but predominantly what you'll find is that your multi-mode cable, your short run cable, is orange, and your single mode long haul cable is going to be yellow. So multi-mode distances for multi-mode up to 275 meters, depending on the speed that you're running. You can get 275 meters. Lately, I know with 10 gig, it's been a brand new world working with 10 gigabit. You can use the same fiber, but usually, I take that back. Usually, you can use the same fiber, but the distance that that same 10 gig will travel isn't quite as far as the 1 gig used to be. So and that's kind of a common principle. If we're retaining the same exact type of cable. So if I were to go back, not to confuse you too much, but this is kind of interesting to me. So Cat5 can run, it's not guaranteed to run 1 gig, but it can run 1 gig, but it won't run it as far. So what they've done, what the standards bodies did, is they said, okay, they used a standard distance, and that was 100 meters. Okay, so how can we keep the same 100 meters going and increase the speed? Well, we have to improve the fiber, or I'm sorry, we have to improve the cable. We have to improve this copper cable here in order to be able to keep this same distance but make it a higher speed. We have to improve the cable. In our fiber, if we keep the exact same fiber, well, we can make the speed go higher, but we won't be able to go quite as far. So we're dealing with physics, and the physics of it will not, the physical properties, the physics of how light travels and how electrons travel are all the same, and we have certain constants. So if we're not going to upgrade our physical fiber optic cable, then we're not going to be able to. This isn't rated for. We won't be able to send 10 gig down 275 meters over multi-mode. We're looking at probably, depending on the quality of cable, probably only maybe 33 meters, right around there. I think is about what we're looking at, depending on the speed. Now we're talking 10 gigabit here, and 10 gigabit is not going to be on your test. Trust me, it's not going to be part of it. They're only going to be testing you on single gig. But I just wanted to kind of give you some real world experience on what you'll find once you get out there and start working on this. Now, these SC, LC, ST, these are the types of connectors, okay? The SC, this is an SC connector here, SC. This is an LC connector. And an easy way to kind of think about it, the difference between SC and LC, LC is the little guy, the little connector. So the little connector is the LC, okay? LC, little connector. The SC, you can think of it as your standard connector, maybe, as an easy way to remember it. Your standard connector. Down here, if you see these little twisties, see how these are? These are metal. If you were to feel them, this is like an actual little sleeve. It's a metal sleeve here. You can grab a hold of it and you push it in and twist. And these little twist style connectors are called ST, and you can think of the T as twist, standard twist connectors, if that makes it, if it's easier for you to remember, okay? Single mode, and you'll see all these different types of cables, all these different type of connections on these cables will be, you'll see them on both multi-mode and single mode fiber. Now the single mode fiber, single mode, like I said, it's your long haul cable, and that can travel many, many miles. You can put repeaters in the middle of it, and all your big telco cable that is owned by AT&T and Verizon, that is in the ground, that's ran across the country, that is all single mode cable. They'll bundle that up into a big giant cable, but when you get down to it, you open that up, it's a bunch of little single mode pieces of fiber optic cable. Ethernet cables some more. So you can, with your copper cables, you have two choices. You can either go to the store and buy it, or you can make your own. Depends on your skill. Now, it's cheaper. I'm going to tell you this right now. It's cheaper if you make your own. You can go to Best Buy or CompUSA or Fry's or whatever, Radio Shack, whatever electronic store you may have. You can buy the raw cable, the raw Cat5, Cat5e, Cat6 cable. You can buy a big box of it. And if you're pulling cable, you already know this, but you run the raw cable through the ceiling, down the wall, and then you're going to buy these little RJ connectors, and then you get a crimp tool, just like this one here, and then you crimp the RJ45 end onto your Cat5 cable. Now, the problem with making your own, yeah, it's cheap, but the problem that you run into is that when you push these little pieces of wire up into the RJ45, they've got to go all the way to the very end of this connector. It's got to get it all the way to the end because it needs to make contact with these. There's little copper contacts that are inside these RJ45 plastic connectors, and if it doesn't make contact with it, you're not going to get a good connection. You don't get a good connection, you're not going to be able to send your data down it. So a lot of times, what commercial companies do when they pull cable throughout a building, they'll have a piece of test equipment that what they'll do is they'll put it on both ends of the cable, and it'll verify that yes, every single crimp that you've made down down this cable is good, and it tests out, and then they can certify it. It gets certified as Cat5. Now, the benefit with your store-bought cables are that they're already tested. They're already tested, and they're already guaranteed to live up to the standard that they've been manufactured at. If it's a Cat5e cable, then it's Cat5e standard. If it's Cat6, then it's Cat6 standard, that kind of thing. The problem with store-bought is they come in very predetermined sizes. You'll have a 3-foot size, you'll have 6-foot, you might have a 25-foot. And so if you need something between 6 foot and 25 foot and the store doesn't have it, you're going to end up with a whole bunch of cable just coiled up around on the floor or in your rack or in your cable chase or wherever or up in the ceiling, and it's going to just it's going to cause, it's just going to be a mess. And in some instances, it could be a fire hazard. Not so much that the cable is a fire hazard, but if a fire were to break out and this plastic burns, it could be toxic depending on if you're in a plenum area or not, and that gets into something completely different. You don't need to worry about that. But so the benefit is with making your own is you can custom make the cables to your specific length that you like. However, if you don't have a way to test the cable, you may not have good crimps, and especially if you're new to making your own cable, it could be hit or miss, and you'll find you'll be snipping off the end and stripping it out and making another cable a whole lot of times before you finally get it right. But so when you make your own cable, you need to make sure that all the cables, the little wires, get put into the RJ45 the right way. And we're going to talk about that here in a second. But there are three different major types of pinouts that you'll see on your Ethernet cable. You have a straight through, you have a crossover, and then you have a console cable, or what's also referred to as a rollover cable. This right here is like your Cisco, your light blue Cisco console cable that you'll get with your switch. That's what this is. And I think that's what the Cisco console is. A console cable is actually a rollover cable. We're not going to really get into that, but primarily I want to make sure you understand what a straight through cable is and what a crossover cable is. So when we start talking about our pinouts, when we take our cable and we trim the outside shielding back and we expose the inner wires, you're going to have four groups of four pairs of wire, each blue, brown, green, and orange. When you split those up, each of the wires will be inserted into the RJ45 in a certain order in order to create a type of cable. So in a standard patch cable, you're going to crimp both ends to be exactly like this. Both ends will be crimped just like the way this diagram shows you here. You're going to have white orange, orange white, white green, blue, green white, white brown, and then brown. And that's the EITIA 568 A standard pinout. Well, there's two, sorry. There's 568A and 568B. The more common is 568B, I'm sorry, and that's what this is. This is 568B. And really the difference between 568A and B, if you look here, this is 568B. This one here is 568A. So 568A, 568B. If you go B to B, you have a straight through cable. If you're going B to A or A to B, then you're doing a crossover cable. Does it make sense? So if you're looking at your RJ, here's the top of your RJ45. Here's the very front. If you're looking at it, what you're going to be doing is you're going to when you crimp these, you got to get them all lined up, and then you just run them down. What's easiest is if you line them all up together first between your thumb and your index finger, and they're all in a nice straight line, just like you see them here, and then they'll all slide in together as one big group. And then once they get to the end, they'll make contact with these end little piece of copper contacts at the end. So you have your standard 568B is what's more common. If it's B to B, it's a straight through. If it's B to A, it's a crossover. Also, if it's A to A, it's a straight through. So you can pin it out at 568A. It's not as common, but if you went A to A, it's a straight through cable. If it's B to B, it's a straight through cable. If it's A to B, B to A, doesn't matter. It's a crossover cable. So I can't remember. Let me jump ahead real quick. Okay, good. All right, so one thing to remember when we're talking about crossover cables and straight through cables. if you're going from unlike devices, from a router to a switch, from a computer to a switch, those are unlike devices. And you can think of a router and a PC are both considered hosts. So if you consider a router a host, a PC or a laptop on your network as a host. So if you go from host to switch, those are unlike devices. You use a straight through cable. Okay. If you're going from like devices, the same type of devices, router to router, computer to computer, switch to switch, you're going to use a crossover cable. And then you're going to need to pin it out this way. So if you notice here, we have the pinout, different types of pinout on both sides. Different types of pinout on both. So these are the same pinout. Same, different. Make sense? And a lot of you probably already know this, but I just want to give you a good overview and make sure you fully understand that we're going unlike devices. We're using a straight through cable because they will test you on this. Using like devices, similar devices, you're going to use a crossover cable. Okay. So now here's the real world. We're putting it all together. This is what it really looks like in the real world. You've run your cable up through the wall, through the ceiling, and over to, say, a closet or a computer room of some sort. You're going to have a small end like this guy here. See this little RJ? This snaps into a jack plate. It's going to snap into a jack plate. Traditionally use a little punch down tool just like this to snap the wires in. Snap, 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 snap. And they go in via the color code. You have the color code is on the side of this. But you use the same color code, use the same exact color code that we have here. Only here we're not making patch cables. Here we're actually running the cable from an office to a closet. So we have our jacks. We punch them down to the jacks. See how here we've taken our wire out. We split it up and we've punched it down exactly the way we need to. And then what happens is then this snaps into the back of this jack plate, and then we screw the jack plate into the wall. Then as we follow this up the wall and over across the ceiling and into our computer room, and then all the cables come out, and then they all get punched down into the back of a nice big patch panel here. See how this guy here, he's punching them down in the back of a patch panel. And then what we do is we then take a patch cable, a regular patch cable that we've made on the previous slide, and we patch it from the patch panel, and we patch it into our switch. Pretty good stuff, huh? This is the meat of it. This is what we do. And this is the real world stuff. This is some awesome stuff. This is exciting. So today, this is what we went over. We talked about the network cards, different types of Ethernet cable. We went over Cat5, Cat5e, Cat6, Cat6a, 7, all the different types of copper cables. We went over fiber optic cables, both single mode and multi-mode. Remember, multi-mode is our short distance fiber optic cable. Our single mode is our long haul, our long distance cable. The multi-mode is traditionally orange. The single mode is traditionally yellow. We have our LC connector, which is our little connector. Remember, our SC connector is our standard connector, and our ST connector is our standard twist cable. And then we finally saw how we put it all together, how we create our Cat5 patch cables. We have a straight through cable for unlike devices. We have a crossover cable if we're connecting like devices that are the same. And then we put it all together from the jack plate all the way through to a patch panel and how it would look in the real world. I hope this has been informative for you guys, and looking forward to the next couple of slides as we're going to start getting closer and closer to less lecture and more hands-on stuff. I hope you really enjoyed yourself, and we'll talk to you next time.